Good morning, everyone.
Good morning.
Welcome to C Seminar with Marty Giles. Let me introduce Marty a little bit. Our guest speaker, Marty Giles, is the owner and operator of Waves Press Discoveries, a marvelous nature exploration tour guide. Marty began guiding tide pool visits when she was just a wee one herself.
A long time ago.
I snooped on the internet. But Marty has been a friend of the sea for years, giving workshops and seminars. Marty has been a friend of the South Coast for longer. Marty volunteers with South Slough, with Oregon Shores, with so many organizations that depend on her knowledge and her joy. So one day a few years ago, I was volunteering for sea out at Dave and V aren't here, but it's the premier site of Central, right?
They were big problem.
Marty pulls up in her big blue van and she jumps out and she's, look at that. And it was an iridescent cloud. I'd never seen one before in my life. So Marty shared that with me. Marty has also shared knowledge with me about what happens when you lick a slug. Your tongue goes numb.
You die.
No, those are new. Don't listen. But if you want your tongue to go numb, lick a slug.
How did you get enticed to lick a slug?
I did not.
Oh, okay.
The Oregon State Park ranger who was on the trip with us threw the short straw, and he licked the slug, and we're, a little ways down the trail, and when does it go away?
It doesn't stick to your tongue because your tongue is wet. Now, if you brushed your teeth against it, you'd have a different issue, but you can lick a slug with immunity.
Marty also taught me the name of the effect that makes the trees, look funny on the coast. And she taught it to me, the Crumples effect.
That's
right?
impressive.
Is that right? I spent like an hour yesterday.
Are you kidding?
Because every time I drive by a, really cool tree, it's like,
And what's it called? The water?
Me
the
too.
crumble.
Oh, okay.
Anyway, the very best things about Marty are the clear love that she has for where we live, the extensive knowledge she has of the natural processes that created our surroundings, and that she takes such joy in sharing this magical place with us.
Well, thank you.
Thank you, ma'am. Now live up to that.
You'll get your check in the morning. Good morning.
Right.
That was lousy. Good morning.
Good morning.
Thank you. Can you guys hear me okay?
Yeah.
Now, I know some of you are retired teachers, and you know how this works. This is the A row. This is the B row. C row, and you guys are in trouble. So if you want to move up, that's great. If you're there because you want to fast escape, that's okay too. I won't call on you. That's okay. So, thank you. Robin, that was really sweet. I owe you now. Okay. So we're gonna be here, Robin said about an hour, so I'm gonna talk real fast, maybe we get done in an hour, because we've got a lot to talk about and a lot of things to do. And, I want to know first a little bit about you. How many of you, are new residents to this area?
Define new.
Oh, good.
Define new. Hard to define new.
What's, how recent is new?
Oh my God, okay. This is your first season, for your first spring and summer? Got a couple? Okay, how many of you have only lived here like 5 years? Wow, okay, a lot. Is there anybody here who's never been down to the rocky shore at low tide? I'm gonna be talking to you.
Where is the rocky shore?
What?
Where is the rocky shore?
That way.
I know, but I just what deep?
About 60% or 60-70% of Oregon shore, about 360 miles or more, depending on how carefully you measure it, is sandy. And the rest of it is gravel, some places cobbles, but rocky. And so if you ever tell somebody I'm going to a rocky beach, you're wrong. Because beaches have sand, which is not a thing but a size, small particles. And the rest of the stuff that doesn't have sand is a rocky shore, not a rocky beach. So, how many of you like to live in Bandon or nearby? Anybody here not from Bandon? Just a couple of you. Okay, not from Bandon, from Bandon.
Who's Bay?
Who's that? Okay.
It's such a long ways.
All right. So I will be talking mostly about Bandon, but about Cape Arago too, well, larger geographic area. And Bandon has, as many areas do, has a challenge of being a rocky shore that has sand nearby. It just makes it a living hell for some of the organisms. We'll talk about that. So we're going to be talking about, how many of you anticipate, or how many of you have been out on the rocky shore to see efforts, and see a lot of people wearing the sea sweatshirts, and talking to people. Your job was to be an interpreter of the rocky shore. So a couple of you, okay, good. How many of you think that's gonna be something I could do? But you haven't done it yet. Okay, so I'll be talking to you guys too. We'll talk about that a little bit. So we're gonna be, here, you promised me an hour, might be a few minutes late, we'll try to talk pretty fast. There'll be opportunities at the end for, even the people who are far away to, ask questions, interrupt me if I say something that doesn't make any sense. It's been known to happen. And I will go back and do that, but there'll be opportunities afterwards. I don't have a deadline. We have to be out of the building at a certain time. 2 hours, we have till noon. We'll be done by noon. People will be tired of me by then, that'll be fine. So we'll talk about that a little bit as we go along. That make sense? Are you good with that? Yep. Nodding heads, okay. No penalty if you fall asleep. So about, some people say as many as 60% of human beings live within 100 kilometers of the ocean or the large body of water. We like water. Some people will say that human beings evolved as a primate species that was intertidal at times. But that's another story. And we love going to the beach. We love being at the water. Very popular spot.
Anything else?
No, not that I can think of off the top of my head.
Hi, what do you want to do?
Thank you.
IT, thank you. We do have 4 participants who are not here that are going through Zoom. So I'm gonna do my best to incorporate them. They're gonna get the worst side of me.
Rob is out here.
But,
Oh, wow.
Could you mute yourself, please?
hi Debbie, can you please mute yourself?
Sure.
Thank you. We may hear from them. So what there are lots, that this is not a class of a catalog of the rocky intertidal organisms. Because there are hundreds of those. I brought a few samples here for people to look at. I wrote a sample about 30 years ago, and I realized last night that I had a whole bunch of them still in the office. So there's some of those for sale back there if you want to take one home. And I think when we're done, I'll take one to the library and donate one to the library. So there are lots of resources that say, what kind of sea story is that? And you can have access to that. That's not what we're doing today. We're doing something bigger today. We're fighting with our computer probably. We're going to be talking about larger stories. Now, most Americans would look at this image and say, oh, I know what that is. What is that? Porcupine. However, a lot of Americans, a surprising number of Americans, would look at this and have no idea what to say. Right? So, and I used to think it was just really dumb to make sure I named everything for people, because the organisms don't care what we call them. But it can be very important because it gives us a relationship with those things. Oh, I know what to call it now. It makes us feel closer to it. Makes it easier for us to get more information about them or to share information about them. And oftentimes the names have a lot of information. But we're not going to do much names here today. We're going to talk about bigger stories here today. This is about natural history. So before we go down to the, I need to organize myself here a little bit more. So before we go down to the beach, I want to talk before you go down to the beach and do some exploring, or some sharing. I want to talk about this morning about larger concepts. Okay. And because the Rocky Intertidal is part of the natural world, I want to talk about this really small type. Sorry about that. I had envisioned a larger screen. There is in the back a couple of handouts if you want to take with you. You don't have to, it's not required. And I'll talk about that as we go along. There's also one of the handouts is what I'm talking about now. And these are a number of years ago. I thought, there's just like a list of things that are found all through the natural world. And I couldn't find a list. So I made one up. And I shared it with a couple of other biologists that I know, and they said, yeah, you got most of it. So we're going to talk about that. One of the great truths of the natural world is that there are patterns of consistency and change. An example of that would be the tides. They're pretty consistent. Change might be climate change, there's big changes afoot, and maybe small changes in the tides, for example. But consistency and change is one of the major patterns that we see in the natural world that we also see in the Rocky Intertidal. At the end, I will review these again and talk about some of these are really well expressed or very clearly illustrated in the Rocky Intertidal. And for me, some of the fun part when talking to people is talk about the big ideas, right? Not just the little things. Oh, that's a sea star. People call them a starfish, and it's not really a fish. Yes, I know we call them sea orcas, and they're not orcas. So consistency and change is one thing. There are harmonies in the patterns. If you think of a pine cone, and you look at the end of the pine cone, there's a spiral there, right? Okay. You think of a hurricane, there's a spiral in the hurricane. You think of DNA, there's a spiral in DNA. You think of galaxies, there's a spiral in many galaxies. So that's an example of patterns that have some harmony at different scales. We talk about ecosystems in terms of communities, groups of organisms that tend to live together, and also about interdependency. This is a big thing in the Rocky Intertidal. We'll talk about these a little bit more in a few minutes. There's standard basic needs, nutrients, water, light, and yes, I know there are communities that are based on sulfur and not have anything to do with light, but that's another story at the bottom of the ocean. Energy transfer is another major great truth in the natural world. Food webs and food pyramids, and the fact that there is no such thing as waste. There's not any such thing as waste. It all gets used somehow sooner or later. Recruitment and mortality is a key issue and a wonderful, we'll talk quite a bit about this here in a few minutes. Succession is another big truth in that a community can affect its environment, that organisms can affect its own environment, and the members of that community can change to be a different community over time. Population dynamics, adaptation, evolution. When you think of organisms in the Rocky Intertidal, you might be thinking of, oh man, that's a really difficult place to live, and it is. And many of those, and all those organisms have to have adaptations to deal with those difficulties. Physical cycles, such as water cycle and watersheds that also affect the Rocky Intertidal, and geologic cycles on a larger scale, including plate tectonics, and also affect in very long range Rocky Intertidal. The butterfly is a way to describe that there's both chaos in the world, but there are also naturally self-organizing systems. There are, I call it a butterfly. Why do you call them? Because you've heard the saying, a butterfly flaps its wings in Japan and it causes a storm in China, or it causes a storm in Canada. Heard that? Yes and no. There are thresholds, and it takes a lot of butterflies flapping together maybe to reach that threshold. But there are self-organizing systems where a small change in the right time and place on the right amount can have a larger kind of a cascade effect to make larger changes. And we're still figuring out all of that stuff. And the last, maybe the most important in some ways, is that we're fallible. We screw up. We don't know everything. We're learning a lot of stuff. And that's another major truth of the natural world, that we're part of it. The stuff about humans and animals. No, we are animals. It's not humans and animals. No, it doesn't work that way. And we don't know everything. We're still trying to find out. As one of our needs as a species is that we have a huge desire to see patterns in stuff. We have to see patterns. Why do we have lucky socks? Always, every time I played baseball, I won when I wore these socks. These are my lucky socks. We have to see patterns. Whether they're real or not, that's another issue, but it's part of our human fallacy and our human drive to see these kinds of things. That makes sense? If this really gets you excited, I have a couple extra copies of this in the back. So now we're going to talk about the rocky intertidal. And you can think about the rocky intertidal as being a combination of non-living elements, water, different kinds of water, substrate, different kinds of substrate. It goes back to your question about our coast and what rocky coast a little bit. And living elements, mostly animals and algae. Do not call them plants because they're not plants. They're different sorts of things. We'll talk about that momentarily a little later on. So this is the stuff you want to talk about. This is, most of these photographs, only a few are not mine, and they're identified, and most of them are taken at Sunset Bay at Cape Arago, because that's where I spend more of my time. And this is Sunset Bay at high tide, at king tide. And you know it's a king tide for two reasons. One is the water. Oh, look at that. That's a non-reflective surface. Look at that. I can't show you anything. I risked my leg by wearing this in my pocket, driving the car. It's a laser pointer and it's not going to work on the screen. So, sorry for you guys far away. This is high tide, you know, because the water goes right up to the cliff because it has a lot of detritus here. This log is moving around. The safety thing you do know, it takes only this much water to raise and move a 1-ton log, right? So it's kind of dangerous. I'm going to point out something here. This is the north end of Sunset Bay. This is where most of the tide pool photographs here have been taken. And this rock right here is in the background of the background image. And I'll point out that rock in a few minutes. This is a high tide, like an 9-foot tide, maybe a 10-foot tide. And there are photographs of people walking on the terrace underneath that water, like 10 feet underneath that water. So tides are a big deal. And in fact, they're such a big deal. Back up. Nope, I can't back. Oh, I can back up. Computers do make our lives better, but sometimes you wonder about that. So the reason that we find the rocky intertidal so cool is because we're land animals. And when it's low tide, the water drops back. And us land animals can walk on the bottom of the ocean, which is pretty darn cool. And we're really thrilled about that because the organisms are alien shapes and they're unreasonable textures and they're bright, brilliant colors. And it's really a cool place to be, isn't it? It's a cool place to be. And it's cool to us because we don't have to do it every single day. I've had people say, can you take us time filming on Thursday at 2 o'clock in the afternoon? No. Can you do something about that? No. So, I want to talk about tides. And I know you know about tides, but I will start the tide story with a story. So many years ago, I was taking a family on the docks in Coos Bay, and I was talking about commercial fishing. The family was a parents and 2 kids, like a 3rd grader and a 5th grader, and they wanted to know, it was her it was their third visit to the Oregon coast. They had a week-long camping trip at Sunset Bay, the third time they'd done that. And they wanted to do something different. They wanted to take their kids clamming. And there were a lot of people clamming, so I was trying to edge them over to doing crabbing instead of clamming. So I said, well, yeah, I can tell you how to do that, but, go clamming, this is summer. I said, you have to get up early in the morning for clamming. And she said, oh, are the clams sluggish then and easier to catch? And I started to do exactly what you're doing. Exactly. Oh, no. Well, I said, in this part of the world, we have 2 high tides a day and 2 low tides a day. And the lower of the 2 low tides here in the spring and summer come in the early morning. Reasonable, short answer. And she said, tides? And for me, I've been tide tooling since I was 3 years old. And it was as if she looked at me and said, moon? It was strange. So I said, I gathered myself real before I showed to her that she just said something that was otherworldly. And really, and she said, and I said, the regular rise and fall of the ocean levels. And she turned to her husband and she said, oh, that's why there was more beach that one day. They were walking on the beach at Sunset Bay, high tide and low tide, and didn't know that the sea level changed. Yeah, my mouth fell open just like that. So I learned something really, really important. And what I learned was that I grew up knowing that tides were, it didn't mean that everybody else did. And so if you were doing interpretation, and I've had this happen to me, have people just stumble across me while I'm in Rocky Intertidal talking to some people, and other people stumble and, whoa, there's this otherworldly thing, I don't have any idea what's here. Why can I see this now? Just totally oblivious. Okay? So I'm gonna go over tides, just for that lady from Sacramento who had never heard of tides. I don't know how that happened. So, you already know this. So you already know this, fine. The restrooms are out through the door. Right, so they've got an escape here for a few minutes. So you know this already, but I'm gonna talk about it anyway, because Robin said I could. You know that the moon is pretty close to the earth, not enormous, bigger than most moons, but pretty close to the earth, close enough that it pulls on the earth. This is a view of us looking down on the earth. Those of you who are in the A and B row can see this. We're looking down on the top of the earth, right? And the earth is actually, the land has a little bit of a tide. The moon's gravitational pull is pulling on the earth, but it's a little bit on the rock, more on the water because it has mass, but it can move around, and also on the air. And as the moon is pulling on the water, it's also pulling on the earth, so there's a little bit of lag over here. And then the earth, as we rotate, going through high tide, low tide, high tide, low tide, not a 24-hour period, but nearby because the friction gets in the way, the continents get in the way. So when the moon is full or new and lined up with the sun, the two combine their forces. The sun's a lot bigger, but it's way far away. And there's a big difference between high tide and low tide, right? At half moon, the moon is pulling mostly on the water, but the sun is kind of counteracting that a little bit. So there's not as big a difference between high tide and low tide. These are spring tides, not because they come in March. These are neat tides because it's not a big difference. Spring like in well spring, right, or water spring. And here neat because they're called neat tides because there's not as big a difference between high tide and low tide. So we're going through in not quite 24 hours, low tide, high tide, low tide, high tide in that as we rotate through that. And it's not exactly even because we're tilted. If you do not know how to read a tide chart, I brought some tide charts. And therefore Charleston, because those are the ones that I had. And if you don't know how to do that and you feel confused by it, see me afterwards and I'll show you how to read it. Okay, they're not that hard, but I've had also run into people who had no idea how to do that. No idea. So we want you to not feel self-conscious if it's confusing, but and I'll help you afterwards. That makes sense? Is this new to anybody? Thank you. You just justify everybody else. Thank you. That's good.
The question is, who understands it?
Who understands
You
it?
can see that often and still not be able to really interpret it.
That's true, but this is one of the, it's very complicated, actually, to do, predict the tides, and we can do it. There are websites you can predict the tides. It used to be a red study, you could predict the tide years in advance, right? There's a lot of elements in it, but we understand the math pretty well if you juggle all the math. I'll show you a picture in a minute. And we can predict it pretty well. It's not absolute because a big storm, storms are generally associated with low pressure. A big storm can make the tide a little bit higher because it's low pressure. And there's some local things and winds and stuff that can mess it up a little bit, but not this much, more like this much, right?
Marty, how does it affect the inland water, the rivers and
How does it affect
other
our-
bodies of water that are not connected directly to the ocean, but
The Great Lakes have a tide.
Yeah.
Not a big one, a little one. The land has a tide. There's a land tide of a couple of inches. And I thought maybe, we have big earthquakes on the planet every once in a while, different places, and I thought the land tide could predict earthquakes. So I went on a site that's no longer currently functioning, and I looked at the tides for January of 1700s, the last time we had a big subduction zone earthquake. And I thought, well, great, there's gonna be great spring tides right before, and that's what, no. Wasn't the case. I was disappointed. I was hoping that, you know how it is. You think, oh, I found out something really cool that everybody will find. No, it wasn't. But it was worth looking for, but it wasn't effective. So on this part of the world this is standard height. I have lots of these. For some reason, I had hundreds of these printouts that didn't get used. There's some in the back that you can take home if you want. And this is really cool because it lists all what these things mean with the different mean high water, mean sea level, all that kind of stuff, right? So in this part of the world, we have 4 tides, as I mentioned, not quite in 24 hours. We have a high tide, a low tide, a low high tide, and a high low tide. Okay? I can't say it more than once. I can say it once. And this is what the tides would look like in the course of a year, maybe. So a guy who lived here seasonally in Bandon, Fred Snively, when he retired, one of the fun things he did was, for fun, he charted his own tide charts. He did the research and the astronomical numbers and all that kind of stuff. And but for his own pleasure, he figured out and predicted tides very accurately. And this is a map that he drew of the tides of Bandon in March of 2013. And the reason I use it is it's quite a cool pattern. It'd be great as a sweater or something. You can wear that. So yes, and you can figure it out. His mathematical abilities were like way beyond mine. I have no idea how to do that. It's way too mathy for me, but it makes a cool pattern. So this is a different website than we'll see in a few minutes. The tides for February 2024 in Bandon. And I got it from this website, tides.net. You can look at the whole month. And you notice that pattern that I showed you, up and down, higher and lower, around the new moon and around the full moon, a little more even at the half moon, right? And these tide range, I think overall the mean is like 5.5 feet. The highest of the high tides this month have been about not quite 9 feet. That would be a little bit, here's 6 feet, this is 3 feet, a little bit below. And you see a couple of times a stretch, I think 5 days when there's some minus tides. On these charts too, the yellow is the daylight and the white is the nighttime. Yes, you can go tide pooling at night, but you see some cool things, but it's kind of dicey safety-wise. So the tides, because the earth is rotating, the earth is tilted, right? That's why we have seasons. And it's a whole nother story how that happened, but earth is tilted. And where we are, we're about halfway between the equator and the pole. And so this is what our tides look like. For grins, I went to the other side of the continent last night and looked at the chart for Maine, the Maine coast, about the same latitude, same distance from the equator and the earth and the pole. The tides go the same way as the sun, and so the continent in the middle has a big effect on how the tides work. And this is what Maine looks like. Different. Really different. When I lived in North Carolina and I went to the beach and I go look at the, the bait shop or something, and they had tides, and they only had the times. Where's the rest of the information? They didn't have it. They didn't need it. Look how regular they are. And there's a long stretch, minus tides, not all that different from day to day. Very different. Also very different, where in bodies of water that are enclosed, like the Great Lakes, perhaps, like the Caribbean, like the Mediterranean Sea. And if you look at, this is an older information, there's a different source that's no longer available. And on this chart, this is in Charleston a week in 2016 that I happen to have on file. The dark green is the sea level. The dark, this is the middle of the summer. The dark stripes are the is the nighttime, and light blue stripes are the daytime. And that's what the week looked like. The mean range was on like 9 feet from the highest high tide to the lowest low tide, and really irregular 9-foot range that week. And look at, this is Key Largo, Florida, closer to the equator and at the edge of the Caribbean, as an enclosed body of water. Look how regular it is. Another place where they just had the time for the tides. And look at this. This is like a 2-foot range. Get to the equator, the tides are like a foot. You get some places the tides are 40 feet, even more if the water is congested like the Bay of Fundy, it's almost 60 feet. But so change it, bigger tides at near the poles, smaller tides at the equator, and they're different in different places. Who cares? Well, who cares? No, the coral reefs do care. That's a challenging thing. Okay, so you can't really talk about tides without talking about, but rocky intertidal without talking about zonation. So when we're walking on the bottom of the ocean, we're walking among organisms that are marine organisms that have adaptations that allow them to be exposed to the air. Also, they're exposed to what else? Other things, we'll talk about that more. And they're exposed to other predators like us, and birds, and raccoons, and other things that go down to the rocky intertidal to feed on the ocean, on the seafood that is now exposed to them. So we identify different zones that are determined by how often that place is exposed to the air, and is limited by how well adapted those marine organisms are to being exposed to the air and the other things that are associated with the air. So I was looking, last night for fun, I was looking at the zones in Maine. And here we call them spray, high zone, mid zone, low zone, and they're different communities of organisms. And the illustrations in the photograph clearly show different groups. Okay, and you can see different kinds of animals as well as plants. When I went to Maine and I looked at those things, it was called the lichen zone, the barnacle zone, the brown alga zone, and the red alga zone, and water. And the images were nice stripes, just like that. And it's all focused on the algae. have an idea why. We'll talk about that in a minute. So, you find out about those zones, when you look at other keys and materials, I said I have some sample materials keys to look at. You will want to do two things if you're out shopping for those things, is to make sure that it's about the Pacific Northwest. If you pick up a book and it's half about, yeah, you have to make sure it's to our species. If it goes on and on and on about horseshoe crabs, probably don't need that one, right? We don't have horseshoe crabs here. That's on the other side of the coast. So, when an organism is a rocky intertidal organism, you can come in, it's okay. Okay. It's exposed to the air, right? This is kind of outdated, a little outdated now, but I love the illustration, so I'm going to use it anyway. And here, on the Oregon coast, we have very moderate temperatures. The difference between mean temperature in January and mean temperature in July is about 15 degrees. Moderate. We have wet winters and dry summers. That's the default for here. We have very little snow. This is the snowfall. And you know, if you've lived here any time, when it snows, big wet flakes, they melt when they hit the ground. You never get to make a snowman. Our daughter made a snowman when she was in junior high at our house in Coos Bay, and she only had enough snow in the entire yard to make the head. That's all she could do. So wet winters and dry summers are really important, right? I'll talk about that more in a little bit. This is a windrows. The longer arrow, the direction of the arrow shows you the direction the wind comes from. The length of the arrow shows you the duration of time over the year. What's missing is really important. What's missing is the time of year, or where the wind comes from the time of year. We have north winds in the summer, brings down cold, dry Arctic air from the north, keeps us cool and dry in the summer. In the winter, the wind shifts around, comes from the south, brings warm tropical air, keeps us warm in the winter, and brings the rain. It's also really important to think about that is because a north wind drives a southerly current. And you have to say southerly, not south. North wind, not northern wind. North wind drives a southerly current. So in the summertime, the currents on nearshore current is going this way. In the wintertime, the nearshore current is going that way. That's important because that's one of the reasons for rocky intertidal people, one of the reasons why the communities are very similar from Northern California to Alaska. Because that current's going both ways. Okay. Want to make sure you nod your head that it makes sense and not that you're falling asleep.
You said normally it was this way, that, so that way, with the east to west.
North and south.
Oh, north and south.
So in the summertime, the wind coming from the Arctic and pushing the water next to the shore to the south. That's why we have upwind. Talk about that afterwards if you want. And in the wintertime, the wind shifts around, comes up from the south and pushes the water that's along the shoreline to the north. We have two currents right offshore going in different directions different times of year. And that's really important for how similar the communities tend to be. So if you get a guidebook for Puget Sound, a little bit different because it's not as much surf, but Washington coast and Oregon coast are going to have the same organisms. Brookings is a little bit weird. You might find more of some things than others, but the same guide will be fine because of that seasonal wind direction. That help? Okay, so here we have a tide pool, right? And it's exposed at low water. So what happens if this is in the winter and it's exposed and it rains an inch and a half? What happens to this water?
Freshens up.
It freshens up. And the organisms that are adapted to live in the ocean, of 32 parts per 1,000 of salt, are suddenly living in a place that's a lot fresher. That can be toxic, right? What happens if this is summer and the sun comes out and it warms up? Some of the water might evaporate and become saltier. That's also challenging. The other thing that happens when the water warms up, if you're out, put your hand in the water, if it's warm, remember that cold water holds more oxygen, and when you warm up the water, the oxygen comes out. That's why water starts to bubble when you heat it up, right? So when this gets warm, it also, some of the organisms will suffocate in there. What happens to the rocks if there's a low tide and it freezes? They're used to temperature that's really regular, or gets hot and it bakes. And you know, if you've gone tide pulling over the course of the year, as the season goes on, these things start dying out. I'll show you a picture in there. Oh yeah, okay. Start dying out because they're exposed to the sun, they dry out, and they're marine organisms. So this is, remember that picture I showed you a minute as a high tide? And I said, this little rock sticking up there. That's this little rock behind that young woman waving at us. That's the rock sticking up. Oftentimes, here's the marine terrace there at Sunset Bay, and you may have noticed, even out here, on a certain level, you see eelgrass, or actually surf grass, which is a different species, in the rocky intertidal. And by and large, the surf grass, first of all, it's a real grass. It's the only thing that's a real grass in the tide pool. They have real roots, they have real vascular systems, they have real grass flowers, they have real grass cities. And they surf grass tends to grow about the zero of the tide level. So this is a really low tide, and this surf grass is mostly dead, because this was August. And if you go now at a really low tide, the surf grass is going to be bright and green and kind of fun looking. But here it's been exposed to a lot of sun because it's later in the year. This is something else that's kind of interesting, but I'll talk about later when we have different pictures. So there's a lot of organisms here. The zonation that shows up on this photograph is probably giving the people on Zoom, making them seasick. Sorry about that. I talked about this being at the zero, the tide level about. And of course, as you go lower, these organisms are exposed to air. These marine organisms are exposed less often. So there are more species that can tolerate that awful situation. Now, on this photograph, you can see what's called feather boa. Kind of a kelp. I've got a book about kelp in the back that we can pull out if you want to look at that. Different kinds of kelp. Feather boa is interesting because when the tide comes in, it moves around a lot, and it tends to clear the space around it. One of the cool things to do when us land animals are walking on the bottom of the ocean, to think about in 6 hours, what's this going to be like? And all this algae that's now laying down and looking delicate and flat and very slippery. When the tide comes in, what's going to happen to it? It's going to move, right? The kelp is very slippery. You don't want to walk on it if you can help it. And that helps keep it from catching in the water, and they'll be swaying and moving, and this will be alive like this deep from the bottom when the water is above it, and the whole community is compressed essentially when the tide is out. When the tide comes in, it's fluffed up and it's its normal self. And you can think about that when you're walking in the rocky intertidal. Talk about that if you're talking with people in the rocky intertidal. Just visiting here, when the tide comes in, the water, if you imagine, put yourself in this situation. Imagine that I took one of you, I won't point out anybody. I took out Clint. I'm gonna take Robin. I took Robin to the rocky intertidal and glued her butt to the rock. When the tide came in, what would happen? She'd drown She couldn't do that. But the organisms that we find so interesting have the opposite situation. They're marine organisms, for the most part, are glued down or maybe trapped in a pool of water because they couldn't move fast enough. And the water went away. You think about a nosebleed, that's pretty amazing that they could do that. So we talk about zonation, it's not just a big thing, because no rocky shore looks like, well, there are concrete rocky shores. And I saw a YouTube article a couple years ago about a breakwater in the UK that they put little pockets in the concrete at different levels to encourage different communities, rocky intertidal communities, which is kind of cool. But it's not just, this is a close-up of that view that we saw a few minutes ago, and then in the crevice. And you'll notice it's all technically in one zone, but there are micro habitats within there. So there are places that get a little more protection from the sun, or maybe from the rain as well, but mainly from the sun, where you'll see more organisms stuck down in places, and other places where there's more bald rock because it's more challenging to live just a few inches away. We'll talk about these guys here in another minute. This is a pretty cool thing. You know what this is? Somebody call it out. Sea anemone. What is a sea anemone? Is it a plant or an animal? It's an animal. It's a predator, right? If you touch it, you can do that. And if you're allergic to these, don't do that. You might have an allergy reaction to the anemone. You can put your finger on the tentacles there and it'll pull you in. Oh, yummy lunch. You pull away. But you don't want to poke it. But if it's an animal, why is it green?
Algae's growing on it?
What?
Is it algae's growing on it?
Algae's growing in it, in the tissues. And the anemones actually get some of their energy from the algae. Like lichen, oh, let's see, I'm gonna grow some lettuces on my arm. Oh, that's a little lunch. And in fact, I was tide pooling once in a cave. It was really low, I wasn't worried about it, in a cave, and the giant green anemones in the back of the cave were so pale. They're lighter than your shirt. They were just pastel. They're lighter than your shirt. They were just, they were, but they're partners. Their symbionts were not getting enough light. This one's closed up, probably because it's eating, because you don't see any of the tentacles. This one is closed up a little bit more. You can see a little bit of the tentacles there. There's a variety of stuff. This is an example of that symbiosis that you often see in the world and sometimes see in the rocky intertidal. Some organisms do an even better job of making habitat for each other. The purple sea urchins here, and the chynoderm, relative of sea stars, sea stars in this, couple of sea anemones. Sea anemones, of course, are relatives of jellyfish. These guys are relatives of sea stars. You know how they work. They've got 2 feet, what sea stars do, but they have spines. And their spines pivot on little bumps on their shell, and they hang on to the rock, and they can move the spines. They also hang on to bits of shell and rock, sometimes on the outside. They move those spines, and they actually would drill a hole in the rock. These guys are living in sandstone, but they can also, which is the main rock in Cape Arago, they can also dig through basalt. Most of the headlands north, Heceta Head and north are basalt headlands, not all of them, but most of them. And starting at Bend and south, the rocks are metamorphic, they're older, they're more irregular. They still drill into the metamorphic rocks as well. So a couple of these guys, holes are empty. The purple urchins have, on the underside, there's a 5-pointed jaw, with 5 teeth on it, has a wonderful name, Aristotle's lantern. Somebody had a great idea about that, and they will come out of their pits and like march around and eat kelp sometimes they'll catch a piece of kelp and run it with their 2 feet down underneath and chomp up the fronds of the kelp. And about the only thing that eats them, birds will eat them, people will eat them. The roe is a big delicacy, I understand, in Japan. The stains of eggs on the inside, and the giant anemones, giant sea stars, the 21 rayed sea stars eat them. And the 21 rayed sea stars had a big population drop with the die-off of the sea stars. And so there's been a huge population increase in these guys, especially to the south, and they're monstrous size armies of them marching through and eating, mowing down the kelp beds, the major concern right now. They can also like live for a long time without eating. So if you wanna, people going out and smashing them under the water and just to try to control their populations until the big sea stars come back. Here, they will live in these holes, and the holes made, especially in harder rock, will have been made by generations of sea urchins. And after a while, it makes a weak spot here, and they can break down. Here are these holes. I think those urchins are just like went hunting in the dark or something and didn't make it home before, which I think is normal. But these holes are great habitat. So when talking about the rocky intertidal on the open shore, the waves can crash with huge power. It's like equivalent to dropping Cadillacs on the rock. So when your butt is kind of glued down there, you're like dropping cars on top of it. Yeah, it's hard. So this habitat underneath the urchins, so you can not get squished by their spines, is really high value real estate. That's where you can find things like lion titans. Sometimes you can find little sea cucumbers underneath there. I've only seen one, a brittle star underneath, but there's sometimes organisms that you can find underneath living in that sheltered environment that was made by the sea urchin. Don't go pulling them out though. It's not, they don't like that. You wouldn't either. Believe it or not, limpets also do that. I was really fortunate to get this photograph. This is higher in the intertidal, and there are micro habitats here. You can see the black spots, the tar spot, it's the name of that algae. And look where the barnacles are. These little these little barnacles have settled out in the cracks. A lot of bare rock. Look at these two limpets. Do you see what made you take your picture? Look at this ridge. These guys have made little spots. So a lot of the organisms are adapted to this habitat and have the water crashing on them and is exposed to the air by hanging onto the rock really tight. And limpets do that. The limpets higher in the intertidal, and they have to hang on tight enough so they're not knocked off and maybe seal themselves off from drying. So don't try to tie them off, you'll hurt them. And a limpet will make a parking spot, hang onto the rock, especially in like a soft or somewhat sandstone, hang onto the rock and grind the shell, apparently, to make a spot exactly its size. And then at night, go out grazing, we'll pick up and move away. This is the head end, the head closer to the point. We'll graze away and scrape the algae off the rocks and then come back to its parking spot. They make their own home, which is pretty cool. I had a photograph somewhere of just the light was just right, and I could see parking spots that were empty. You could tell by the shape, size and shape. We had a computer crash and all our photographs got scrambled. Not the photographs, but the filing was, so I could not find that one. But I have this one. So you can look for that when the light is kind of glancing off the rock. You might find parking spots. Evidence of this invertebrate making its little home and keeping a little bit of protection for itself. So we think of the coast, we think of maybe mussel beds, we think of sea stars, we think thought, well, should I use this photograph? It's kind of fuzzy, it's an old photograph. And well, I can talk about these things. This is a giant green anemone, and this is an aggregating anemone. And aggregating anemones are interesting in that they clone. And one individual aggregate, they're the ones that are small, maybe that big. And they have pink tip tentacles and they live higher in the intertidal, so people run into them. And sometimes you can see a soft mat on the rocks that is just, what is this weird, soft, bushy mat? You touch it, it squirts out at you, and I'm not gonna sit there. And what they're good at, they reproduce like everybody else, like almost everybody else, sending out gametes into the water. But aggregating anemones also reproduce like cloning. They don't get much bigger than like a walnut. And I'll make a bigger picture with my hands. You guys can't see it at all, sorry. Bigger picture of my hands. And later in the season, they'll get bigger and bigger. And then you'll see some that are oval, like this one, the lower in the far left corner. There's an oval one. You'll see ones that get oval longer and longer, and whoop, they'll pick themselves off, and there'll be two genetically identical individuals right next to each other. And they'll keep doing that over time. And you can have a patch of aggregating anemones that are clones of one individual. They don't like other individuals necessarily. And if you look closely, sometimes you can find one patch and then another patch and an alleyway between them. And what's happening, the ones over here are stinging those over there. The ones over here are stinging those over there, and they leave that alley. So look for that pattern. We love looking at patterns in the rocky intertidal. This is an unusual photograph in that these things are kind of jumbled up. This was taken here where the rocks off Bandon. Normally when you see, think of the zonation, you think of the beds of mussels being a very specific environment, and they are. The mussels have those threads that come out and hang onto the rock and each other. And so if you're a mussel, you're hanging on the bird, and you're hanging on the rock, and you have this habitat. The mussels are shaped in an oval, and so they're packed together. There's space between them and underneath them. That's another really high value real estate, and a lot of things are found under here. Again, more delicate things that you wouldn't find elsewhere. If you were to take part of that mussel bed out, take out a square foot, study was shown down in California, and took out a square foot of mussel bed, mature mussel bed. Took 7 years for that to grow back in. A foot. Took 7 years to fill that in. So, and there are places where the two mussels are growing bigger and bigger, and they'll actually release off the rock. You've seen that. And if you're a fisherman, you watch fishermen, something pull out when several come and there's a bald spot underneath. That's a long-term change on that habitat. We know that the top of the mussel bed is determined by the ability for the mussels to survive out of the water. That's the mussel's top. What is their bottom to the mussel bed? Sea stars. Sea stars! Yeah, these guys. The bottom of the mussel bed is the top of the sea star's tolerance for being exposed. Some of them will get in there a little bit, but it's the top of the sea star's tolerance. How do we know that? So some researchers some years ago found a small cove, I don't know where, small rocky cove. They put a fence up underwater, the rocky cove, and then inside the cove, they took all the sea stars out. These are ochre stars. Yes, they come in orange and in purple, like Labrador retrievers come in different colors. They took all the sea stars out and they kept monitoring it. And in a number of years, that mussel bed went all the way down to the bottom. It was 100% and all the surface of the mussel bed. So the sea stars are actually flipping that off, which is pretty cool.
Meaning they eat them.
What?
They eat them?
Yes, they eat them. So, Robin's gonna demonstrate with me. I'm the sea star, okay? And Robin is, thank you, Robin is the mussel. And the sea star, these are the common sea star, and the ochre stars. And the sea star tries to pull over the mussel, and the mussel's stronger, but the sea star's more patient.
I gotta bring sometime.
Yeah. The muscle finding is hard, opens up just a little bit. Doesn't have to open up much. When you're so good at this. And so when that happens, the sea star can hold it open. The sea star takes its stomach out of that hole in the middle, right? Sea star takes its stomach out of its body, pushes it inside the shell, digests the muscle inside its shell, and that food goes into the body. You can hear it. Can you see her expression? That was good. And then when the sea star's done, the mussel's dead and the sea star's eating it, and it pulls its stomach back in, and goes away. Gives a whole, it gives a whole, thank you. It gives a whole meaning to the expression going out to lunch. Okay, so I know that for a couple of reasons. I know that because I've seen videos, you find videos online of the sea star, they speed them up. They put a piece of meat on the glass, and just comes up, and then goes away. So they had to speed it up, right? I've also found gumboot chitons, the great big chitons, with acid. I saw one with the sea star on top. And I picked them up and the sea star came right off. And where the sea star was, the sea star's stomach was still out, so the gelatinous mass there. And when I pulled them apart, there was an acid burn on the gumboot chitin. And then the sea star went, with its stomach back in. We're so cocky, we think everything else is like us.
Well, you said the sea star has 2 legs.
And the sea star has 5. And all, echinoderms are 5-parted organisms, like, sea urchins are 5-parted, sea cucumbers are 5-parted, crinoids are 5-parted, they're all, echinoderms are the same, we'll talk about that one, the same 5 body parts. Okay. So it's not the only part of the of rocky intertidal. Intertidal, the tide comes in, and the tide has a lot of food in it. Many of the organisms are filter feeders, like barnacles, and just some sample algae that I picked out because I thought they were cool looking. Phytoplankton, plankton means the drifters, minute organisms that make their own food, and zooplankton, many organisms that are animals. A high percentage of zooplankton are larvae. At the bottom here are 2 crabs. Crabs start off free swimming. Most rocky intertidal organisms start out in life free swimming, not the aggregating anemones, but most of them start out that way. There's another anemone that also pops babies out of the side, but they start out looking not like crabs. This is one early stage. This is a next later stage of a crab, and when it goes molts from this one, this stage it turns into it looks like a little thumbnail-sized crab and settles out of the water. This is a barnacle. Very much alike. Barnacles are closely related. They're crustaceans. And the difference in the barnacles are that the barnacles get to a certain stage when they're ready to settle out. And barnacles, all these organisms, the larvae are sweeping in and out with the tide. The barnacle that's time to settle out, I'm not thinking that way, but it is time for them to do that. And so the barnacle finds rock and starts taking the rocks with its antenna. So it finds a place that suits it. When it finds a place that suits it, it turns over, it glues its head to the rock. The body changes shape and they end up shaped like a volcano upside down, and then spends the rest of their life taking their food into their mouth with their legs. When the tide comes in, or look in a tide pool, you can see barnacles opening, and these legs sweeping like that. Those are like the legs of a crab eating food. Like crab, they have internal fertilization, and barnacles, we have all adults here, yes. Barnacles have, acorn barnacles have, for body size, the largest penises in the animal world. Because they reach out, way over there, because they stay the rest of their life in that spot. Now, that's a barnacle. Some of these are, and in this illustration, again, I just picked them out because they were cool looking, are in the water their whole life. a dinoflagellate, microscopic in its life, in the water whole life, like this is a baby squid. We've got other small polychaete worm in the water its whole life, arrowworms in the water its whole life. This is a fish, baby larva fish. This is a larval clam in a medium stage that will eventually get big enough to fall out of the water. This is an embryonic sand dollar. I got a quarter in my pocket for anybody who wants to guess what this is an embryo of. Young embryo. I got a quarter. I don't have a quarter in my pocket. You ever want to take a guess? It's a bilateral organism, has two parts like we do, right? It's mirror image on left and right, almost mirror image on left and right. Any guesses what that is?
Titan,
What?
Titan,
Who said that? Say it again. Say it again?
a Titan,
A chitin.
Titan.
Good choice, not the right one. So then we talked about echinoderms being 5-part animals, including sea stars. This is a newborn sea star. Has 2 body parts instead of 5. So they'll go through a stage. I haven't seen it online. I'm sure you can find it online. They go through a stage that is metamorphose. They change and they turn. I've seen videos of this, and they turn themselves inside out, like in a minute. Turn themselves inside out, and when they do that, they end up with 5 body parts. I don't get the math. It's pretty amazing. If you ever have to use the that's effing amazing. It's pretty amazing. You start out with 2 body parts, and they turn themselves inside out, and you've got 5 body parts. But you kind of don't do that. So that is a newborn sea star. These are many of these things. Dun 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 dun. Actually, that one too. And this one are larvae. Okay. So they're in the water. The organisms, those organisms put their gametes in the water. They get together. If you do it right, you can get a whole pool, tide pool of sea urchins sending out their gametes at the same time, and the water will turn to like milk because they're hey, somebody else is sending out the egg. I better send out the sperm. Oh yeah, and they did a big like an orgy happening in the tide pool, and then they put out huge numbers of gametes, and then those are moved around by the water. Okay. Remember, in the summertime, the wind usually comes from what direction? In the summertime, it comes from the north, keep it cool and dry. And the water is moving that way. So gametes get spread that direction. In the winter, the wind is coming from the south, so the water is going that way, and that's why it's spread out. Okay? The recruitment into the tide pools. And then when they settle down, the ones that settle in a bad spot die. The ones that settle in a good spot don't. And that's how we end up with the zonations. So again, think about what that's going to look like at high tide. You'll have go back at high tide. That's really fun to do. So tide pooling in the morning, and go back later when the tide's in and go, wow. You can imagine when you're down in a rocky tidal and the water starts coming in and it like washes over the rocks you're just like looking at. You can almost sense the organisms going, the hell of a place to live. So we talked about these great foods. Constant scene change is a big one that is one that's illustrated in a big way in the rocky intertidal. The tides, primarily. Communities, we talked about various communities and interdependency, not in habitat that some of the organisms live in sometimes the organisms are living inside, hermit crabs, using other shells, things like that. It's a good place to see that, great truth of the natural world. Recruitment and mortality is the big thing that relates to where the organisms are. The water is the recruitment source for all their rocky intertidal, and the mortality is what makes the zones. For the most part, the babies end up everywhere, or almost everywhere, but most of them don't make it in that habitat. We talked a little bit about different adaptations, just a handful of them for living in this really challenging environment. We talked about physical cycles, both in the tides and in where we are in the rainfall. I suspect that tide pooling in Maine is really different, looks different to me, because they have colder winters and hotter summers. So when it's low tide in Maine, it's more likely to be very devastating to organisms that are living in the rocky intertidal. I can't prove that, but most of you are like going, yeah. Okay. So we vote that that's true. Geologic cycles also affect the rocky intertidal. The shape of our current shoreline in Oregon is only about 6,000 years old. Sea level's been higher than that. That's why we're in a flat place here, and lower than that. And sea levels change, land plates change, and that also, in the very long run, affects the rocky intertidal. Butterfly effect every place. And the rocky intertidal is also highly affected by the great truth about human fallibility. We love it. We go down to the beach and we pick up shells and we do things like that. We shouldn't pick up shells. We talked about that a lot here. Especially in the rocky. In some places you can't pick up shells in the rocky intertidal. At Cape Arago, at Sunset Bay, if you're in the rocky intertidal on the north side or the south side, you cannot take the shell that you find there home. If the same shell were on the beach, you could take it home, but not in rocky intertidal. We'll talk about why in a minute. Well, we already talked about it because it's habitat. I'll give you a good story. If you have not done that, you know this stuff already. Dress in layers, no flip-flops, please. In the beach, that's not safe. Long pants, because the barnacles are sharp. The only thing that's really going to hurt you, unless you're allergic to these things, crab might pinch you. Don't put fingers in the crack if you don't know what's in there. Don't pick up a kelp crab. Kelp crabs are adapted to hang out in the slippery kelp. And if you pick up a kelp crab, beautiful red-brown crab with that pointed legs, pick up a kelp crab, it's going to wrap itself around you and hang on to you as if you were a piece of kelp, and you will not get it off there without a significant amount of pain. So the rocks, the barnacles, and crabs are going to hurt you, so wear long pants. See people showing up tight pooling, bare feet, and short pants and world apart. Keep your hands free. Don't carry your phone or your camera in your hand. And this one I can speak from very personal experience. Make sure your back pockets are empty. You don't want to sit settling on your keys. Trust me on that one. It's a safety issue. We are visitors to the rocky intertidal. Right? And so, as we're visitors, we're going to have some good etiquette. This is something I thought was important enough to print out. I'm going to ask Robin to help. This is a two-sided thing. There's high pool etiquette on one side and some safety tips on the other side. I'll get this side. Thank you. But I think this is important enough. We are curators of now you didn't know you were sitting here. We are visitors, and so we want to be good visitors. We want to be safe visitors. There's some extra stuff on the back about safety. For those of you who are zooming in, we'll send it to you. Or email it to you. I got the two in the back. We want to talk about etiquette. Watch your step. Watch your step, not just for them, but also for you. So put your foot on bare rock, on sand if you possibly can. If something is shiny, it's going to be slippery. Think of the slipperiest place you can imagine. Think of wet lasagna noodles. Think of slip magazines all piled on the floor and anyway. So that's a safety thing as well as an etiquette thing. There are some, you think, well, these organisms are adapted to big waves crashing on them. Yes, but that's different than your feet. And it's a lot different from a walking stick. Unless somebody can only move with a walking stick, and that happens sometimes, I encourage no walking sticks because it's easy to poke that down in a hole and just crush the dickens out of what goes in the bottom of the hole. Okay, now watch your step where you're looking. Keep your knees, for safety, keep your knees bent, your body, your center of gravity a little low to catch yourself. Go with the idea you're going to be observing rather than collecting. All right, we've all seen people go down with their buckets. Oh, we're gonna take some sea stars home. Oh, they call them starfish. We're gonna take some starfish home. I remember driving on US 101 from Newport to the Valley once, a long time ago, and there's some pullouts along the way. And there in one of the pullouts was a pile of sea stars that was this tall, this wide. They got halfway home and somebody said, "Oh, those things stink, dump them out." Just go with the idea you're going to be observing rather than capturing anything. Touch them gently. If your hands are wet, that's great. You spend like you're a toddler in one finger touch. Right? So touch them gently. If you pry, it will die. Talk about limpets. Sea stars also hang on to the rock as a way of keeping them from being torn off and keeping them from being eaten. And for some of them, like the limpets, keep them from drying out. But if you pry them off, you're going to rip off whatever structure they're using, your foot or the 2 feet, and you're going to hurt them. If you pry, it will die. And the other thing to remember is keep it low and let it go. You can lecture all you want to people about not picking things up. But if you have a 10-year-old, you're with a 10-year-old, and they see a hermit crab, they're going to it's like the sun rising and you're not going to stop it. And then the trick is you want to keep that, if they have something in their hand, low, because the hermit crab will come out of the shell and start walking around. When they do that, they tickle. And what does the kid do? And that's a long one, right? So keep it low and let it go. Replace all material you might move, whether it's a rock, whether it's a piece of driftwood or kelp, because that is making temporary habitat underneath. That's important to those organisms. Don't take it home, alive or dead. Find a pretty shell in the rocky intertidal, any place, but in the rocky intertidal, and it's, oh, there's nothing on it. No, you look at it and you'll find little shells. You might, even if there was empty, there's nothing on the inside, which is still a snail, you know the snail's still there because all marine snails have a door, have a curriculum, and you'll pull the body in and there'll be a door there. You know, door, that's no worries, I can take this home. No, first of all, you might be wrong. Secondly, when that shell, even if it's empty, is worn down in the chemistry of the seawater and the surf, the calcium carbonate that makes the shell is freed up into the water, and then other organisms can use it. And here's another reason you don't do that. You started typing one time. So when I was in high school, I took a group of fourth graders typing the Central Oregon coast. I wasn't old enough to drive yet, so I was riding the school bus with them. And I admonished them, we went to Marine Garden, north of Newport, and I admonished them, you're not going to take any shells home. No shells. No. No, I admonished them. On the way back, we're driving along, and the squirrel starts screaming bloody murder. And what's going on? She had what she thought was an empty shell in her pocket. And the hermit crab did not want that. And the hermit crab was walking around in her pocket, and it panicked the dickens out. That's what I told you. Anyway, she said, oh, it's empty. I can take this one home. And it wasn't empty. So it's habitat, either whether you see it or maybe habitat later. and it's also a natural resource. So don't leave it there, alive or dead. Take photographs and nothing else. There's specially designated areas, and that is, we've got to the south of us here, the sandy shore that's set aside for, western swimming shores. There are the islands, as you probably know, I didn't read the brochure, we know about the larger rocks are part of the Oregon Islands National Wildlife Refuge. Those are off limits. There's also, the rule that if you see a pinniped, a marine mammal on the shore, seal or sea lion, and you do anything that makes it change its behavior, it's a visitor too, but if you do anything that makes it change its behavior, you're technically breaking federal law. Because you're disturbing, because now it's moving off the beach or whatever. So you want to be careful about where you're going and look at that designation. And there's also a bit of etiquette in sharing what you know or what you see or what you observe, demonstrating good etiquette, answering people's questions or whatever. If you look like what you know, be like, I don't know if this happens to you, sometimes in the grocery store, I'll have people I don't know constantly say, you know such and such here? Don't you have a name tag? But that will happen to you, and especially if you're one of those really good people that is considering being an interpreter and talking to people about these things. And some of you've already done that. How's it feel?
It's fun.
It's fun. It's wonderful. You get to see it in their faces. And sometimes I talk to people who stumble into that. And what's going on here? And their eyes are like this big. I've also met people, and you may have too. I had a woman tell me once, why do you want to go down the beach? Just look at the slime. Yeah. I was careful to disguise my reaction. What is wrong with you? So, being able to share that and help other people grow their appreciation of this intertidal habitat, of our ability as land animals to walk on the bottom of the ocean and witness these processes, witness these adaptations, witness these organisms, is really a special thing that you now have the opportunity to share. You guys have any questions? I put you to sleep.
I assume you've been to the Charleston Marine Life Center.
Yes.
But I would just encourage anybody that wants to see these critters up close and personal. I mean, I've seen sea urchins are releasing eggs and sperm.
Yeah.
In the tank, you can see the sea stars with their stomachs out.
Yeah.
And so it's amazing the stuff you can see there. You spend some time.
And it's so cool. And the neat thing about some of those things is people, oh yeah, starfish, I know what starfish are. It's a remarkable thing.
Yeah,
That is cool. They've got the touch tank.
Yeah.
They've got videos upstairs. Don't miss the videos upstairs. They have videos of some of these larvae doing their larvae thing in the water.
cool stuff.
Yeah.
They're open Wednesday through Saturday,
Wednesday?
11 a.m.
Yes. Thank you. People are asking about resources, and I'll get to your questions in a sec. There are some resources back there. I also have some pieces of paper that say this. We'll make this available to you guys across the way. This is the website that the state parks put together about 10 years ago or so. And it has tidepools.org. And I printed the top of the page out because there's a species list. I can't look at this without my glasses. That's kind of embarrassing. That's not trip tips, species guide, and things like etiquette and other kinds of stuff. And this might be an online source. Again, if you're looking for paper or other sources, make sure it's the right coast. Unless you're looking at some of the books that I have that I brought that I like have good information about tides or about something else, even though they're mostly about the other side. This is the organisms from Central California, Northern California, up to Alaska are generally really reliable. You can see that here. This is mainly for Oregon. species that has the more common organisms listed in the species guide and little, information about each one. Give that some background. So there, that, I printed those out so we can remember people, but OregonTidepools.org.
Yeah, so if they study everything, I wondered how far limpets travel from their rural.
You know, I don't know. There are people at OMB, I think, who have measured that. I don't know. I know they are not, they tend to be nocturnal and they move around at high tide. So I would imagine, I don't know, it's a good question, not like from here to downtown. But probably, they probably have, maybe half this room, maybe, or at least a quarter of this room that they graze around and come back. The mollusks that do the grazing have, tongues, round tongues, radula, that have little points on them, like kind of like a cat's tongue. But many of the mollusks have little metal on the tips of that. And the black leather chitin, one that gets maybe about that big, that's black and shiny. Chitins have, chitins have 8 plates, and the black leather chitin has, the plate is mostly covered by that shiny black thing. Black leather chitins have teeth on the radula that are tipped with iron. Okay, and remember that flat marine terrace that we saw in the photograph of this one? This marine terrace, there's a mussel bed here and a pretty deep, like a -2 foot tide. And that this marine terrace, I always thought was a sea level thing. Well, that's natural, I understand that, but it's a little bit higher. Well, maybe the land's rising, the land is rising a little bit. And, Dr. Cynthia Probich told me that, well, that's made flat by the black leather chitin. By lifting the algae off the rock at that level, they'll flatten that out and make it real flat. And if anybody else had told me that, I wouldn't have believed them. Anyway, so those organisms are changing the habitat in large scale as well.
Marty, I was, kind of surprised that you didn't mention the kelp bearings with the, sea urchins eating.
Yeah, I mentioned it,
No,
maybe
sea
I
otters.
said it too fast, that because of the die-off on the sea stars, that apparently affected the large sea stars the most. I mean, there was some concern that they were going to go extinct. They did find some of many-rayed sea stars, in Newport recently, little babies. And they gathered like a dozen of them or something. They gathered them, they were gonna raise them up big and then let them go. Those big sea stars, they didn't get up to like that big, up to 21 arms, eat urchins. One of the few things that, well, birds will eat urchins.
Sea otters, though, was my.
And sea otters will do it too. And sea otters, of course, we shot the last sea otter in Oregon, I think 1906. And sea otters have tried to bring them back. They haven't managed that because, thank you. The sea otters are social, and the ones that they brought just got homesick and left. I did once see a sea otter at Simpson Reef at Shell Island. I'll digress here a little bit. So I went to a program at OMP, the guy, and some of them have been there several years ago. The guy who was talking about problems, the state of Oregon's sea otter expert. And he said the sea otters are big, mean weasels. Sea otters, they look so cute. They hold hands, under the tail. Sea otters have been known to rape seals and hold seals and kill seals. I mean, one sea otter was at least one known to drag that seal around for a while. Sea otters, there was a sea otter at Simpson Reef, a number of years ago. It was this little errant. He was a teenager that decided to run away from home. And we were watching the sea lions on the beach. And this sea otter came out of the water. They rarely do that. Came out of the water. And those sea lions got the heck out of its way. They parted. Sea otter was like sniffing at them and they just gave way. The sea otter. It was pretty amazing. So we shot all the sea otters, right? Or bought them, got rid of all the sea otters. And the sea otters could eat urchins. so the large sea stars died back, and because there are no sea otters to help with that, especially south of Port Orford, the purple urchins just started marching in big hordes and mowing down the beds of bullet kelp. Sea urchins, can go zombie. They can live for apparently a year or more without eating. They just kind of get weak and shriveled up, and then if they're food, they spring back up. So it's been really hard to control them. So that the barons, they call them, because see photographs underwater, you just see huge areas of purple balls and nothing else.
And I think one of the real issues with reintroducing sea otters is that they require kelp beds.
Yes,
And, you know, and the urchins, when they get like that, they start just putting off all the baby kelp, and so it's hard for the kelp to.
right, and they cut off the kelp.
Mhm.
Lower kelp, the main, member of our kelp beds, have one float.
Right.
So if you interrupt it, boom, it's gone.
Right.
And so that is a big issue. It's kind of chicken egg thing. You need the otters to keep the urchins under dough, but you don't have the otters because the urchins have eaten all the kelp and, you still have some kelp beds, but not like they used to.
Why it's so important to
Yeah.
preserve the kelp beds that we do have.
And the kelp beds, again, it's a habitat that's vertical. And so they're a major habitat for a wide variety of organisms, not just otters, but other things that we do. Yeah. Subtitle, and don't care. Any other questions?
I'm just gonna put in a little word about Shoreline Education for Awareness. Thank you so much, Marty, for having your presentation.
This kind of stuff, right?
Yeah. If you're interested in becoming a member, just check out our website. And if you're interested in becoming a volunteer as well, this is what we do. We have 2 sites, actually 3, a Cup Watch and then Simpson Reef and Face Rock, that are, we have volunteers in the summer months, on the weekend, interpreting what you see, both in terms of bird population and intertidal. Check out our website if you'd like, and if you have any questions about membership or volunteering with their volunteer coordinator, and you can see you have membership.
If you plan to volunteer in Rocky Intertidal, in the back is a publication that I put together a long time ago. It's 2 pages, so I didn't make it for everybody, about how to interpret in tide pools. And there's one demonstration copy. If you want me to send you a digital copy, put your email address on the list and I'll send it to you.
Yeah, and we've got a plethora of things for you to check out.
Yeah, and including a little slip of paper, if you don't want to try to remember the URL for working tide pool stuff.
Marty, the other thing I would add to that is we are designating social point in Marine Garden. And we're gonna have signage at the little kiosk going down the steps to explain the etiquette, tide pool etiquette. Cool. What you would see in the tide pool.
Good.
May we use your tide pool etiquette sheet?
Yeah, please do.
Copy that in, okay.
Yeah, please do. The tide pool etiquette sheet that you have, I took off of this website,
Okay.
and I didn't cite it because I wrote it. So, yeah, you have my permission, and I think the state parks would say, yeah, that's okay. If you wanna cite, OPRD, that would be appropriate too. And especially if you wanted to cite OregonTidePools.org, because again, there's, what it is, I take the most common organisms that people see, and it shows a picture of it and tells you a little bit about those organisms. And that might be a good resource, especially if there's cell phone service down, I think there is, down on the beach there. So, yeah, thank you for asking that. Anything else?
Thank you.
I kept you a whole half hour on that. Thank you.